discussing about asymptotic notations in DAA, design analysis of algorithm. So by using asymptotic notations we can calculate the time complexity of algorithm. So we can calculate algorithm time complexity. Okay, also we can calculate best case, worst case, average case, time complexity of an algorithm. సో మనం ఏం చేయవచ్చు అంటే ఈ నోటేషన్స్తోని మనం యావరేజ్ కేస్ని, బెస్ట్ కేస్ని, వరస్ట్ కేస్ని ఫైండ్ అవుట్ చేయొచ్చు. ఓకేనా, ఆల్గరిథం యొక్క టైం కాంప్లెక్సిటీ. సో టైప్స్ మనకి ఏమేమి 3 టైప్స్ ఉన్నాయి: బిగ్ ఓ నొటేషన్, ఒమేగా నొటేషన్, టీటా నొటేషన్. సో బిగ్ ఓ నొటేషన్ రీప్రజెంటెడ్ లైక్ దిస్, omega notation, theta notation. So big O notation for worst case, omega notation for best case, theta notation for average case. So coming to first one, big O notation. Big O notation, it mainly represents least upper bound of an algorithm at its runtime. So it represents least upper bound. So big O notations measure the worst case time complexity. So big O notation means it will measure the worst case time complexity. So let f of n and g of n are two non-negative functions. Then f of n equals to big O into g of n. Okay na? Taking f of n, g of n. So f of n is equals to big O into g of n. So in order to prove the above formula, so what f of n equals to big O of g of n. So in order to prove the above formula, we need to satisfy condition. The condition, that is f of n less than or equals to c into g of n. Okay na? If there exist two constants c comma k such that for all n greater than k. So example we are taking here, see, f of n equals to big O into g of n, right? So we are taking f of n, this f of n as 2n plus 3. So taking formula f of n less than or equals to c into g of n. So f of n, what is f of n? 2n plus 3 less than or equals to c, means we are taking here c means 5, taking c as 5. So 2n plus 3 less than or equals to 5 into n. Okay, so graphical representation of big O notation. So time, number of inputs, so f of n, c into g of n. Okay, next coming to second one, omega notation. So omega notation, it mainly represents greater lower bound of an algorithm at its runtime. Okay, omega notation measures the best case time complexity. It measures the best case time complexity of an algorithm. So let g of n and f of n are two non-negative functions for omega notation. So f of n is equals to omega into g of n. In order to prove the above formula, we need to satisfy the condition. So this condition we should satisfy in order to prove this above formula. So f of n greater than or equals to c into g of n. Here f of n less than or equals to c into g of n. Here f of n greater than or equals to c into g of n. If there exist two positive constant c2 and k such that for all n greater than k. So we are taking f of n is equals to 2n plus 3, f of n 2n plus 3 greater than or equals to c into g of n. So c equals to 1 we are taking here. So 2n plus 3 greater than or equals to 1 into n, means 2n plus 3 is greater than 1, right? It's proved. Above formula is proved. So next, coming to this theta notation. So no, see here, graphical representation for omega notation. Okay, so time, number of inputs, so here c into g of n, here f of n. Okay, so theta notation, it represents the exact bond. Means exact bond means both upper and lower of an algorithm. Okay, theta notation measures average case time complexity of an algorithm. Okay, mathematical representation of theta is, so it has mathematical representation. So c1 into g of n less than or equals to f of n less than or equals to c2 into g of n, this. Okay, so f of n is equals to 2n plus 3 we are taking. Okay, this f of n. So c1 into g of n less than or equals to f of n 2n plus 3 less than or equals to c2 into g of n. So we are taking c1 as 1, c1 equals to 1, c2 equals to 5. So c1 1 into n less than or equals to 2n plus 3 less than or equals to 5 into n. Okay. So graphical representation for theta notation. Time, number of inputs. So f of n, c1 into g of n, c2 into g of n. This is the k value. Okay. థ్యాంక్ యూ. మీకు ఏమైనా డౌట్స్ ఉంటే కమెంట్ బాక్స్లో కామెంట్ చేయండి, నేను రిప్లై ఇస్తాను. ఓకేనా? థ్యాంక్ యూ.